Today we're going to be learning, for us, it's 4.1. Wow. Okay. We're going to call this max and mins. One of the best things about calculus is that we're going to be able to tell what's going on in a graph based on different things that we've been able to do so far. Meaning we can have a graph just with the formula and we can determine maximums and minimums by doing derivatives. And I'll show you that in just a minute here. But first off, let's define what maximums and minimums actually are. So we're going to have something that we're going to call the absolute max. And it's if I have like a graph that looks like this. And I have something that looks like this. There's a value right here that we are going to call the absolute max. Because there's no other value of f, or no other value at all, that's like bigger than it. That's the biggest value we actually have. We also have absolute minimums. I'm going to draw that right next to it. I'll get better with this, I promise. It looks something like this, right here. That's my absolute minimum because there's no other value that's going to be less than that. So we call that our absolute minimum. So if I look at this graph right here, I have an absolute maximum value, but then the values here as x goes to negative infinity and x goes to positive infinity are negative infinity. There's no absolute minimum. And just like over here with minimums, over here the values are going to go on forever upward, and so there's no absolute T. I can spell, promise. No absolute max. Oh dear. There we go. So what we can do is like, okay, well, there's no absolute min, there's no absolute max on those ones. But what about a graph that looks something like this? We have these values right here and right here. We'll say this is like -3, and this one's like 3. But if we look right here, because this is going up forever, there's no absolute max. There we go. And then over here it's going down forever, so there's no absolute minimum either. So we have no absolute maximum, no absolute minimum. So there's a graph that has it like this. But what we can do is we can say, what is the absolute maximum on this interval -3 to 3? I look at this and say, okay, well, this part is obviously that absolute maximum or minimum. This part right here is the absolute maximum. So we can say here on that interval from -3 to 3, this is going to be my absolute minimum. And this is going to be my absolute maximum. Maybe I should have drawn it differently because I have no absolute max here, then that's an absolute max. Only if we have defined an interval right there. But just because we have an interval defined, let's say from A to B, doesn't mean I'm going to have an absolute maximum minimum. Because if I do this, there's no absolute maximum value here because as this function is getting closer and closer and closer to that value, it's not going to exist. But I can get infinitely close to it, but it's not going to be there. So the limit exists, but there's no absolute value because for whatever value you give me, I can always find one bigger to it that's closer to 3. or closer to whatever value this is. I said 3 because it looked like 3 right there. So we have things that we can do to like say, hey, look, we can set an interval and we're going to be just fine. And we can absolute maximums. And then we have these things that are like not continuous or annoying. They like jump around. So things that look like this. Hey, look, that's not an absolute minimum because we have this point right there that doesn't work. Okay, so I'm going to go over here to definitions real quick, and I'm just going to come up here to look at the absolute maximum and minimum. So this is just saying, hey, look, it's an absolute maximum if it's bigger than everything else. If f is bigger than everything else. If it's smaller than everything else, then it's an absolute minimum. We call them the absolute extreme values. So oftentimes these are extreme values. Well, I don't know why that's happening. Okay. These extreme values are maximums or minimums. So this extreme value theorem right here just says, hey, if it's continuous on a closed interval, A or B, it has an absolute maximum. So if I just have like an interval right here saying, hey, here's my interval A to B, and I have something that looks like this, then I have an absolute maximum, I have an absolute minimum. Sometimes it'll look something like this. So the endpoints are your maximums or minimums. Okay, so these are absolutes, like the biggest things in the whole interval or the biggest things in the whole graph. We also have what we like to call local maximum and minimum values, which is that if there's anything that could buy it that's not close to it in a small area, some interval I, then it's a local maximum or local minimum. And I'm going to come back to our examples over here, meaning I'm going to bring back this beautiful graph again. I have this guy right here. Okay. Don't laugh too hard while you watch this video. There we go. Then I can say, hey, look, this is not my absolute maximum because I obviously have values over here that's bigger. This is not my absolute minimum because I have values over here that are smaller. But this is a local maximum, and this is a local minimum. And if you look at these, you're thinking to yourself, okay, well, why is that important to me? Well, I look at this and I say, okay, well, look, what's the slope of the tangent line at this point right here? Can I pick a different color? Oh, you guys, this just changed my world. Okay. Look at the slope of this tangent line right here. And the slope of this tangent line right here. Notice that the slope of the tangent line is 0. So we'd say f prime of x equals 0 will give us a local max or min. Nice. So the question then becomes, how can we tell if it's a maximum or a minimum? And you guys are going to figure that out in your problems. The answer is you look at points around it, either the function or you can think, is it increasing or decreasing? We'll talk about that later. So just know that it'll be a local maximum or minimum. Um, what about absolute values? So it's true that sometimes the local maximums or minimums can be absolute maximums or minimums, but if I have an interval, let's say a to b, and within a and b I have f prime of x equals 0 when x is equal to c and d, so there's two different values that I have in there. If you want to check for absolute value, the absolute max or absolute minimums, you have to find out what f of a equals, what does f of b equal, f of c equal, and f of d equal. And then if f of a is the smallest, it's the absolute minimum. If f of c is the biggest, it's the absolute maximum. But we know right here that f prime of x equals 0 at these 2 points. Therefore, notice that we're not doing f prime, we are just doing our functions. So that's going to be important to note. And if I go back to our definitions and look at it, that's we have these extreme value theorems that says if it's a local maximum or minimum at c and the derivative exists, then the f prime of c equals 0. Great. So we know that. If it's a local max or min, the derivative has to be 0. A critical point is another thing we call these extreme values. A critical point is defined as if the derivative is 0 or the derivative fails to exist. It's called a critical point. You're thinking, what? Why would it be the derivative failing? Well, here's two examples where the derivative fails to exist that are critical points. Look, the derivative doesn't exist right there, and the derivative does not exist right there. So this is 4.1, just maximums and minimums of a graph. In your examples that you do in class, you're going to see, oh, here's how we use these kinds of things. This is just the information that I feel like you're going to need in order to, start in class. All right, see you next time.